Now that we built this procedural object and refined it, it's time to think about rendering. Today I want to give you an overview of Redshift inside of Houdini and of the rendering-related concepts of Houdini. This time is the first time in this course that we actually will need the shelf. So make the shelf visible by clicking on this line here. And here the shelf with all its distracting goodness is again. If you installed Redshift successfully, you will find this Redshift menu here. This tells that Redshift is installed, and you will find a Redshift shelf. Click on this Redshift shelf, it shows a lot of Redshift related tools. If you don't have this shelf yet, just go to this plus button here, and under shelves you will find the Redshift shelf. If you enable this by ticking it on, then you will find this Redshift shelf. And these buttons here are used to create Redshift-related nodes that are necessary to render with Redshift. Inside of Houdini, rendering uses two different contexts. Of course, first the object context containing all the objects, but then the material context that is used to define your materials, and the out context that is used to use render operators, ROPs. These render operators are holding all the render settings. So the very first thing you want to do is to add a Redshift ROP to the scene. By clicking on this Redshift button here in the Redshift shelf, you're creating a Redshift ROP in the out context. And you are not only creating one ROP, but two. And that is because of the Redshift interactive preview render that needs a second ROP. It has technical reasons. Don't think too much about it. This one that says IPR is just for the interactive preview render. This one, the Redshift ROP one, is the actual Redshift ROP. This node here just holds all the Redshift render settings. So all the settings for the renderer are bundled here as parameters to this node. And this system is a little bit different than in other applications, where you usually have a dedicated render settings dialog or something similar. In Houdini, you have a render operator network. And that can be used to do really complicated and intricate things, like, for example, first render your scene with one ROP with distinct settings, and then as soon as this render is finished, launch a second ROP to render effects that rely on the results from the first ROP, stuff like that. So pipeline things can be done by chaining ROPs together. But to just use Redshift as a renderer, this is not necessary. We can just rely on this one ROP node here. If you are used to using Redshift in Maya or Cinema 4D, you will feel at home immediately. But at the moment we cannot render yet, because we don't have a camera and we don't have a light. So let's switch back to the object context. And let's create these. Let me make the parameters a little smaller, maybe the viewport a little smaller too. To create a camera, just Control-click on this camera icon here on the Lights and Cameras shelf, and it will create a camera that uses exactly the view you have in your 3D view in the moment you press this button. So this is our camera. If you navigate the viewport now, you are going outside of the camera. So now you are not looking through the camera anymore. You can change this with this little menu here, where you can specify which camera to look through. As soon as I do that, you see that I'm now looking through camera 1, indicated by this red border here with these handles. But again, as soon as I navigate, I lose the connection to this camera. And this behavior can be changed if I link the camera again, if you just invoke this lock here. If this lock is on, then this camera is locked, and I can navigate my viewport without losing the connection to my camera. Okay, great. Next is, I need a light. And because Redshift is a third-party rendering engine, it comes with Redshift-specific lights. And you find these here in the Redshift shelf. So here you have the Rs light. Same story. Control-click on this light, and you will create a light exactly where your viewport camera is set at the moment. Although this is a light and not a camera, Houdini automatically links this light to your viewport. You're now looking through this light, and the reasoning behind this is that it makes it easy to place the light, because now you can just navigate your viewport to place your light. If you want to go out of the light now, just invoke the lock, dive out of the light, and switch to the camera, invoke the lock again. Now I have placed the light in the scene, and I am inside of my camera. This light icon here shows where the light lives in the scene, and here we have the light node. If you click the light node and go to the light tab, you find this light type drop-down. And if you open it, you see that Redshift comes with 4 different light types: distant light, point, spot, and area light. The distant light is a light where all the rays that come in as light are parallel. It can be used as a sun, for example. The point light is a light that emits in all directions. The spotlight only emits in the Z direction, and the area light is a light that has an actual area to it. For our indoor rendering purposes, let's create an area light. If you do that, the icon changes, and now you have an area light that you can place here in the scene. In Houdini, lights have a distinct gizmo to move them around. Not only can you move them by using these axes, but you have this rotation-like gizmo that you can use to target your light. So by using these axes here, you can target your light to your object. The light intensity is controlled not in the light tab, but in the shader tab, because this is a light shader. And here you see that by default the intensity is set to 100, which might be a little intense for our purposes, so go down to 5 with this. Now that I have a camera and a light, I can invoke preview rendering. And while Redshift is capable of making use of the internal Houdini render view, it comes with its own dedicated preview render window. And that is the render view that you find here in the Redshift shelf. So if you click that, it takes some time, and then this window opens. And it immediately starts rendering. And you see that you get a beautiful result because we have a light and a camera. So now, if you move your camera, the connection is live and Redshift updates in real time. So all the changes to your camera are reflected in real time in this render view, and it's very easy to make your changes as you immediately see what you are doing in your render. To be able to operate your render view properly, let's talk about these buttons on the top of the window. First you have this button here, which is used to do final renders, and then you have this play button. That is the most important one, because as long as it is pressed, Redshift will render. So now I make live changes. If you click that, then the connection is stopped and no update happens. If I click this again, then the scene is resent to the graphics card and the rendering is restarted. So sometimes this is necessary if something goes wrong. Then you have this refresh button, which will refresh the data on the graphics card without stopping the render. So if I press this, everything gets resent to the graphics card again. And although Redshift does a pretty good job in updating all the changes that you make to the geometry and to the shaders, to the camera and so on, sometimes there are changes that are not reflected immediately in this window here. And if this is the case, then you have to press this button. Then you have this drop down to inspect AOVs. But we don't deal with AOVs today. Same here for this button, which makes it possible to view individual channels. And with this button here, you can create a render region, which you can resize here directly inside of this window. And as long as this is on, Redshift will only update this little area here. And then comes a very important button, because Redshift is a biased renderer, and it comes with 2 distinct render modes. First, it has progressive rendering, like other GPU renderers. That is what you see here. So it starts to shoot the same amount of rays for all the pixels for the entire image, and then refines the result by shooting more and more rays. So if I move my object, you see that it starts quite pixelated or quite noisy, and then it cleans very quickly. That is a progressive mode. But Redshift is smarter than that. It has something called adaptive sampling. So it has an engine built in that can figure out where to put more samples and where to put less samples, related to where more samples are needed. But this adaptive sampler is only available in bucket render mode. So if you press this button, you switch Redshift to bucket render mode. And you've seen already that it rendered with buckets, and now you get the result with all the settings that you have in your render ROP. So now you get exactly what you get with your final render. You still can navigate your viewport and get updates, but it takes a little longer as it uses this bucket rendering technique. As a side note, Redshift comes with a lot of optimization techniques that are point-based, like irradiance maps, for example, and these only work in this bucket mode too. So while this bucket mode is more precise and shows you the final result, and while it is more effective and should be used for final rendering, turning this off and using the progressive mode is good for look dev because it just updates faster and you see your results faster. And then you have these buttons here that are for snapshots. Okay, now while navigating the viewport, you see this black area here. What is this? Well, by default, lights in Redshift are visible. So if I navigate like this, you see the light. And because an area light only has one side that actually emits light, the other side just is black. And we don't want that. So go to the light and to the light tab and just disable visible. That makes the light invisible in the render while retaining its effect on the object. So that is a better behavior. Now let's create a material. Let's close the render view and go to the material context. If you press Tab here in the material builder, you find a plethora of nodes because this is a big mixture of all the nodes for Redshift and for Mantra. So you have all the Vex nodes for Mantra in here, and it's really a lot of stuff. But if you type RS, you find a selection of RS related nodes, and the most important one is the RS material builder. If you create that, you create sort of a container for Redshift material networks. And if you dive inside, you find this Redshift material output. But this is not the actual Redshift material. It's just a collection node. So it's the node that holds the outputs that go to the renderer. And you will create your materials here inside of this network and connect them to the different ports of this Redshift material output node. You have surface here, displacement, bump, environment, volume, shadow, photon, and you can use these individual ports to drive all the different effects of the render. To be able to use this, let's create a material. So type RS and you see now that you are inside of this Redshift WAPnet, you have a subset of nodes and only the RS nodes are available to you, which is easier. Create a RS material. If you press Tab and go to materials, you see that Redshift comes with different materials. But the RS material is, so to speak, the Uber material because it is a material that can be used to create plenty of different material types. The other ones are either easier or less intricate, or they are dealing with special effects. So don't think about these yet. Let's concentrate on the material. If you create one of these, you get this material node and it has an output color port. And that can be connected to the surface port of this collection node here. Now you are telling this entire Vex container that the surface is defined by this material node. And that is all that you have to do to create a basic Redshift material. If you go up one level, now I have this material and I can name it. Let's name it sculpture. And I can use this container node to apply this to my object. And that can be done in different ways. You can drag and drop, or you can go back to your object context. And if you click an object, in our case the volumetric onion skins for example, and you go to the render tab here, you find this material field. And this material field just links to the material that you want to use. You can drag it in here if you have both windows open, or you can use these familiar buttons. Then you get this chooser. Just navigate to the matte context, and in here you find the sculpture node. And if you click this, the path gets put here in this field, and now the object knows that it should use the material called sculpture from the matte context to render. If you now open the render view again, you see that not too much has changed. The object is a little bit darker and now it is glossy because the standard material just is gray. Now switch back to your material context drive inside the material container, and now we can do changes to the material live. So this is just a PBR material, so it uses a physically based rendering paradigm. And that means that it cares automatically about things like energy conservation and proper Fresnel and stuff like that. And that just means, if you don't want to dive into PBR theory too much, that it will give physically correct, beautiful results by default. The material itself comes with different tabs, but the most important one is this base properties, because it holds all the properties that I normally used on most of the materials. There is a diffuse section, a reflection section, a section that deals with refraction, and then a subsurface section. And as you might have guessed, you can use the diffuse color to define the diffuse color. So if I go in here and change the diffuse color, it immediately changes in my render. And with reflection, you can go in and dial up the roughness to make it more rough, for example. The individual sections work a little bit like layers, and all of them have a weight parameter. And this weight can be used to dial in or out the entire effect. So if I, for example, go to 0 here with diffuse, everything turns gray, and the only thing that you see here is reflection, because diffuse is not calculated now. You can do the same thing for reflection, so you can turn it off entirely. This is not physically correct, but Redshift has the ideology of really putting the power to the user, so it's up to you if you want to render physically correct or not. So maybe let's choose a little more pleasant color for now. And now we have a shaded result. Go up one level, and by alt-dragging, duplicate this and call the second material container spheres, because we have a second object in our scene, the spheres. Go in here and just change the color for now, and go to your object context and apply the second material to the spheres by choosing it here. And now the spheres turn blue. So now we have an object with materials on it and a light. But everything is very dark still, because we have a main light, but we don't have ambient light and we don't have GI yet. So before we create an HDRI light and some GI, let's stop the render for now and create one more thing, a floor plane. So just lay down a grid that serves as our floor plane and move it down such that it does not intersect with our object like so. And let's go quickly to the mat again, duplicate this material again, call it floor, and apply it to this grid. Maybe we call the grid floor 2, render, and then apply the floor material like so. Let me show you a quick workflow tip. It's tedious to switch using this menu between the individual context, especially with rendering. You have to switch very often between material and out and object. And what I do is I create snapshots or shortcuts. If you are in a distinct context and you press Ctrl and a number, so Ctrl 2 for example, it sets a quick mark. And you can do the same thing with OBJ. Ctrl 1 sets a quick mark of 1, and out. Ctrl 3 sets a quick mark of 3. And now you can just jump to the individual context by pressing 1, 2, 3. It just jumps to the quick marks. And that makes it very fast to switch between the individual contexts that are needed for shading and rendering. Okay, to create some additional HDR lighting, we need a RS light dome. So create one by control clicking on it, and this will create a RS light dome. This is just a dome light. And if I invoke my rendering again, you see that now this is just a lot lighter, because by default the dome light is just a white light. And the floor is blue because we did not change the floor material yet. Let's make the floor material a dark gray, like so. But the dome lighting can be enhanced a lot by using an HDRI map. And I downloaded one from SIBL, the online free library or resource of HDRI maps, and I will use this now. So if you go to your light dome and then to shader, you now can specify a dome map here. If you do that, just quickly navigate to directory, and I use Old Industrial Hall from SIBL. And just load in the EXR, and it shows immediately in the viewport, and it now shows in the render. Now you have the lighting from this HDR image. But it not only affects the lighting, but if I quickly go to Materials again, and into the Sculpture material, and dial down the roughness, you can see that it affects the reflections too. So the reflections use the dome map now. Let's make it a little bit more rough, like so. Great. So the last thing for today is to turn on global illumination. And as global illumination is an effect of the render engine, we have to go to the render settings that can be found in the out context. So go to the Redshift drop, and under Redshift you have a plethora of settings, one of them being global illumination. And at the moment the GI is set to none. So it's only calculating the direct light. And it looks as if this is already global illumination because the HDRI map creates light from all the directions, in this case. Nevertheless, there is no light bouncing and no light creeping into these cavities, so switch this to brute force for now, and you immediately see that the result looks far more realistic, because now we have all this bounce light here. So that's it for now. That's a very quick introduction to Redshift inside of Houdini. Next time I will go into the details, and we will shade this object using vertex color and build a proper shader for this object that reflects what you see in the title graphics, and I will explain to you in depth the settings of the Redshift drop, rendering final images, how the adaptive sampler works, and what the global illumination modes do. So thanks a lot for listening, and see you next time.